Greetings to everyone. Myself Sachin Satyarthi, student of Department of Civil Engineering, Faculty of Engineering and Technology, University of Lucknow. I am here to present seminar presentation on landslide. Moving on the table of content, these are the table of content. First one is introduction, then causes of landslide, effects of landslide, landslide risk assessment and mapping, landslide mitigation and prevention, early warning system and emergency response, case study, conclusion, and references. Our first slide is introduction. A landslide is a mass movement of rock, debris, or earth down a slope. It occurs when the force of gravity acting on a slope exceeds the resisting force of the slope. Landslide can be triggered by various factors including saturation of the ground can reduce its stability, shaking can destabilize slope, eruption can cause landslide, deforestation, construction and mining can weaken slopes. There are several types of landslide: sudden drop of rock fragments, overturning of rock masses, movement of coherent masses of rock or soil along a plane, shallow movement of soil, rapid movement of debris mixed with water. Now, next is geographic factor: rock type and structure, rock strength. The strength and stability of rocks vary widely. Weak, fractured, or weathered rocks are more prone to landslide. Rock orientation: the orientation of rock layer can influence the direction and stability of slope. Faults and joints: these structural features can weaken rocks and create potential slip surface. Slope angle and topography: slope steepness. Steeper slopes are more susceptible to landslide due to increased gravitational force. Slope shape: convex shape building outward and concave shape curving inward can have different stability characteristics. Topography features: ridges, valleys, and cliffs can influence slope stability. Soil properties: soil composition. The type and composition of soil, clay, sand. Soil moisture: water can significantly reduce soil strength and increase the risk of landslide. Soil structure: the arrangement of soil particles can influence its stability. Groundwater: water pressure. High groundwater pressure can reduce the effective strength of soil and rocks. Water table: the location of the water table can affect slope stability. The next one is environmental factors. First factor is rainfall. Heavy rainfall is a primary trigger for landslide. The intensity and duration of rainfall can determine the amount of water that infiltrates the soil, leading to increased pore pressure and reduced soil strength. Frequent rainfall events can gradually saturate slope, making them more susceptible to landslide over time. The spatial distribution of rainfall can affect the location and severity of landslide. Second one is climate change. climate change models predict an increase in global precipitation, particularly in certain regions. This could lead to more frequent and intense rainfall events, increasing the risk of landslide. Higher temperatures can accelerate soil erosion and weathering, making slopes more vulnerable to landslide. Climate change may alter weather patterns, leading to more extreme events such as drought and heat waves, which can indirectly affect landslide risk. Now, the next one is effects of landslide. The first one is environmental impact. Landslide can cause significant erosion, leading to loss of topsoil, damage to vegetation, and disruption of ecosystem. Landslide can release large amount of sediment into rivers and streams, affecting water quality, aquatic habitats, and navigation. Landslides can destroy habitats for wildlife, leading to loss of biodiversity and ecological disruption. Landslide can degrade soil quality, making it difficult for plants to grow and reducing agricultural productivity. The next impact is societal impact. Landslide can damage or destroy homes, business, and infrastructure, resulting in substantial financial losses. Landslides can pose a serious threat to human life, and fatalities can occur when people are caught in the slide or affected by debris flow. Landslide can disrupt essential services such as transportation, communication, and utilities, causing inconvenience and economic hardship. The experience of a landslide can be traumatic for survivors, leading to psychological distress and emotional problems. The next one is landslide risk assessment and mapping. First one is component of landslide risk assessment. Hazard identification. This involves identifying areas that are prone to landslide based on geological, hydrological, and topographical factors. Vulnerability assessment. This involves evaluating the potential consequence of landslides on people, property, and infrastructure. Risk analysis. This involves combining hazard and vulnerability assessment to determine the overall landslide risk. The second one is methods used for landslide risk assessment. Field survey, collecting data on slope stability, soil properties, and vegetation cover. Remote sensing, using aerial photography, satellite imagery, and light detection and ranging to map landslide prone areas. Geographic information system, integrating various data layers to create landslide susceptibility maps. Numerical modeling, using computer models to simulate landslide behavior and predict potential impacts. Third one is benefit of landslide risk assessment and mapping. Early warning. Identifying landslide prone areas allows for early warning system to be implemented. Land use planning, guiding development away from high risk areas. Emergency response planning, developing effective emergency response plans to minimize damage and loss of life. Mitigation measure, implementing measure to stabilize slope and reduce landslide risk, such as reforestation, drainage system, and retaining walls. Moving on to landslide mitigation and prevention. The first one is prevention measure, avoiding development in landslide prone areas and restricting activities that could trigger landslide, planting trees to stabilize slopes and reduce erosion, implementing measures to prevent erosion such as contour forming and tracing, installing drainage system to divert water away from slopes and reduce pore pressure. The second one is mitigation measure, constructing retaining wall, gabions or rock anchors to stabilize slope, implementing system to monitor landslide prone areas and provide early warnings to residents and authorities, developing plans for evacuation, search and rescue operation and disaster relief, raising public awareness about landslide risk and promoting safe practices. The next one, early warning system and emergency response. Early warning system for landslide are crucial for protecting lives and property. These systems involve monitoring landslide prone areas and issuing timely alert to individuals and communities at risk. Component of an early warning system. Monitoring network. These networks use various technologies such as rainfall gauge, seismometer, and ground motion sensor to detect signs of potential landslides. Data analyze. Data collected from monitoring network is analyzed to identify trends and anomalies that may indicate an impending landslide. Alert system. Once a potential landslide is detected, alerts are issued through various channels including sirens, mobile phone notification and public address system. Challenges in implementing early warning system. Cost. Installing and maintaining monitoring network can be expensive. Early warning system may not always provide accurate or timely alerts, especially in complex geological environment. Public awareness. Raising public awareness about the importance of early warning system and how to respond to alerts is essential. Evacuation plan. Developing and implementing evacuation plan for landslide prone areas to ensure that residents can be safely evacuated in case of an emergency. Search and rescue team. Training and equipping search and rescue team to respond to landslide and locate survivors. Disaster relief efforts. Providing essential supplies such as food, water, and shelter to affected communities. Infrastructure repair. Coordinating effort to repair damaged infrastructure such as roads, bridges, and utilities. Challenges in emergency response. Access. Landslide can block access to affected areas, making it difficult for emergency responders to reach those in need. Coordination. Coordinating the efforts of multiple agencies and organizations can be challenging during a disaster. Resources allocation. Ensuring that adequate resources are available for emergency response efforts can be difficult, especially in areas with limited infrastructure for funding. Now, moving on, case studies. The first one is case study of Wayanad landslide. The Wayanad landslide of 2024 were a series of devastating landslides that occurred in the Wayanad district of Kerala, India on July 30, 2024. These landslides were triggered by heavy rainfall, resulting in significant loss of life and widespread destruction. At least 250 people died in the landslide. Unofficial estimate put the death toll as scores remained missing a week after the calamity. In an estimated 5,000 people are affected. The tragedy has triggered a debate around the way climate change impacts have been ravaging Kerala in particular and the Western Ghats in general. A focal point is the report of the Western Ghats Ecology Expert Panel, popularly known as the Ghatsil Committee report. The report proposed stricter regulation of development activities in this zone, including restriction on building and infrastructure development. Another committee headed by K. Kasturiranjan was formed to examine the report and suggest a way forward as the proposal to curb development activities was found problematic. Climate change is turning costly for Kerala in terms of human lives and economic loss. The 2018 floods alone cost the state over 40,000 crore rupees. Now, the second case study is Indonesia landslide. Heavy rainfall has been affecting central Indonesia, particularly the Java Island, since 29 June 2024, triggering a number of landslides that have resulted in casualties and damage. The Indonesian National Board of Disaster Management report as a 3 July 2 fatalities, 100 persons still missing and 100 injured people due to a landslide event occurred on 30 June in the area of Bumirejo village, Blitar Regency, East Java province. In addition, the Asian Disaster Information Network ADIN report nearly 300 affected people, 26 damaged houses and 3 damaged bridges across the West Java province. Also in this case, due to landslide events occurred in the same period, over the next 48 hours, more heavy rainfall is still forecasted over most of the Java Island. These are the references. Thank you for your valuable time.